Okay.
I think it's
So,
fixed
which question is it? Which question? Here's your homework, right? So,
yeah. I think it fixed it because it said I had a 32% or
yeah,
30.
I have to manually fix it. You see, so for this one, you put a dot or something here and the correct answer 0 here. However, I accept it. That's why I had to manually fix it here.
Oh, okay. Yeah, because
Okay. So, any other question from you guys? Let me know. Any other
I'm
question?
good. I'm
Okay.
good.
Okay, so if you don't have any question, let me go with chapter 3 here. It's a developing a program. And that if you remember about the program development cycle, normally you have the four step, right? So when you think about the problem solving principle here, it's the same. The first thing you always have to completely understand the problem here. That is very, very important, right? So think about you ask you think about you have the requirement about the make the cookies. You totally understand what is the requirement here. How many cookies? What's a size? So all right. So what is a recipe? You need a milk, or you need egg, or you need chocolate chip, or you need it overcooked, or you need it crunchy, or something like that. You have to totally understand. The more you understand, the more in detail you understand it, the more success you have with the program here. Right. So once you understand the problem, you have devised a plan to solve it. So when you have the plan, you already stick to the plan here and you just carry out the plan. And after that, after you've done with something, you have to review the result here, right? So we see it totally meets the requirement or not. So if it's something not meets the requirement, you have to come back to fix it. The same with the program here. So in the program, normally you have the 4 major steps here. The first one, you have to analyze the problem. So the same as that one, you have to totally understand what is the requirement here, what is expected output. Right? So from the output, you are able to figure it out. What are the inputs here? Right? So when you already analyze the problem, you can design the program. And when you design program, you list down all of the steps you have to do. You have to figure out what is the algorithm and what is the modular you have to working on that. So when you have design, you go with the coding here, right? The code. So you stick on the design, you translate from the design to the coding. So the design here, it can be a pseudocode, it can be flowchart or whatever it is. But when you understand the logic of the program, it's very easy for you to translate it into specific program here. So you think about when you understand the logic of the pseudocode, it's very easy for you to translate it into the C++ or Python or whatever it is. And the first one is a test program here, right? So we have to, again, you have to make sure that the output is what you expected here. If something going wrong, you can go back to fix it. You can go back to fix it, whatever it is. That's why the code is a cycle, right? Cycle, that means you always able to go back to fix it here. Okay, so first thing you have to analyze the problem. That is very, very important here. Right? The more details, the more you understand about the requirement, the more success rate you have with the program here. So the first thing in the analyze program, always you have to identify what is the desired result here. That is output. Right? So think about you want to make the cookie here. Right? That is the example I was giving out here. So the first thing you have to identify how many, right? How many cookies and what's the recipe you want? You want is something about crunchy or not or something like that, right? And what is the size? And so once you understand about that, let's say you need the 5 cookie and it's crunchy, that is the output, right? So from that one, you have to figure out what are the input here in order to make the 5 cookies here. So we have to figure out all of the input here. So you have the flour, you need the flour, you have the milk, You have egg, right? Something like that. Eggs, chocolate chip, something like that, right? So when you have the input here, when you have the output and input here, you have to think about what is the plan to do with that, right? So you have to devise a plan here. You have to devise plan how to mix them together, right? So remember, in the RLI program here, the first thing always have to figure out what is the desired output here. All right, so from the output, you're able to determine what's the input in order to produce those output here. Okay, so think about here, the program here, you create a program to generate the SIG number to play the lottery here. Is this okay? What do you think? Is this okay? Generate the SIG number to play the lottery. It's okay, right?
Yeah.
Because we have the SIG number here. This one also okay. This one also okay. All of them okay. If you the requirement here, it generates the SIG number to play in lottery. But you think about that, the output here, you have to very, very specific on that one. So think about this is the desired output here. It's not only the SIG number, but it's much be 6 different and positive integer and integer from the 1 to 40 here. So when you look back on this one is not correct, right? Because they are not different. This one is not correct because it's negative here. And this one also because you have to integer from the 1 to 40, right? So we see in the RLI program, in the figured out the output here, you have to very, very completely understand the problem, and you have to very, very specific on the problem here. You think about that, the more specific you are, the more success rate you have. So that is the RLI program. Now, when you have the output already and you have the input, you have to think that how can you mix them together? How can you? So you don't have the input, so you have to think that how can you? What is the formula? What is the recipe in order to work with the input in order to bring out the output you want here? Right? So you think about if you want to mix a cookie, you must have the recipe here. Or you have the formula here. So how can you do them together? And you have to list out all of the instruction here, all of the steps, right? In step by the instruction. The first one, you have to mix the flour with the milk. The second one, you have to crack the eggs. The third one, you have to mix them together, right? So you have to put in the chocolate chip, and you have to put in the oven, and you have to set the time and something like that, right? You have to figure out all of the formula here step by step. It is an algorithm. It is an algorithm. The algorithm is a step by step in order to solve a problem or complete the task here. Right? So normally in the design program here, you have some way to do that. You can use a chart here. So when you study on this module, you know that you're able to use the flow chart. So flow chart here. So we see everything in order, right? So you enter the input and you do something with calculation, and you have the output here. That's the first thing you're able to use the chart here. The second one, you can use the module that when working with the modular structure, if you think about the complicated program, you're able to break it down into module here. Right? We will study about the module structure later here. Or you can use the ordinary language, is a pseudocode here. The pseudocode is also the step when working the design program here. So we think about, if you look it back in the example of the pseudocode I gave you on the chapter, in the chapter 1. It's the first thing you always figure out what is output, what are the inputs, and from that you have to figure out the formula, right? So from that you're able to do with the pseudocode here. Okay, so the algorithm is must be the well-defined, well-ordered here, right? So we have well-defined, and it must be in the order, and it must something you have to produce some design here, and it must terminate in the finite time. Right? So if you think about some of the loop, if you're working with the programming here, sometimes you're facing with the loop at its ending loop, it never ended at the end here. But the algorithm must be something terminate in the finite time here. So if you look it back on this one, these two steps are very, very important here. The more the detail, the more specific, the more you understand about the problem, the more success rate you have the output of a program here, right? So when we think about program, analyze and design, they are two most important steps in the in the program development lifecycle here. And the coding, actually the coding is very simple. When you understand the logic of the design here, you just translate it into the specific programming language here. And the last one is the testing to make sure that the output is what you expected here. And if something not going well, you have to go back to fix it here. Okay, so the third one is the coding. Translate. You have translate the chart. So think about, you look on the flow chart here. You understand that for this one you have to put the input, and for this one you have to do with the calculation. You have, and you just translate from the chart or module or pseudocode here into the programming code. For this class, when working with the coding, is that when you have to work with the Rudder here. The Rudder is not programming language. It is a simulation of programming language. But however, when you understand the logic of the pseudocode, and when you understand the logic of the Rudder, it's very easy for you to translate it into the specific programming language here. And in the coding, or sometimes you have to add statement here to the document. So to think about, if you have very long programming and you have a very complicated programming here, so sometimes it's very hard for you to follow all the coding. So it should be better if you have some of the comment, some of the documentation to help you to follow with the coding here. And they normally break it down into internal and external documentation here. And for each programming language, they use specific syntax here. So think about some of the language, when you set x equal to y plus z here, they require you have to put the semi-comma, the comma here. But some of them, they are not. Right? So you have to, when you work with a specific programming language, you have to understand what's for the syntax here. And if you remember, you have the two types, the error. The first one is the logic error, and the second one is a syntax error here. So do you remember what is the logic error and what is the syntax error here? Any idea for that? What is the logic error and what is the syntax error?
Syntax error is like when you don't use like the proper syntax, like you write you write things.
Okay. So the syntax error is the error that when you execute program, it will stop and
it won't work.
Yeah, it not work. It will stop and it giving you out some notification.
Oh. And whereas logic error is, well, the code will run, but it won't output the desired output.
Yeah, right. Good. So the logic is a program will execute normally, but the output is not what is expected here. I think about, if you want to figure out the area of the rectangle here, you have the length and you have the width here, right? So the area, normally you have to set area is length times width here, right? Okay, but somehow you put the length plus width here. So when you execute program, nothing wrong. But the output is not what you expected here. That is the logic error. And the syntax error is everything about, you think about the, if you have a program here, you have to set x equal to y plus z, and it requires the semi-comma here, but somehow you forgot it. So when you run it, when you execute it, you have got the syntax error, and it tell you that you have the notification error here, and you have to adding the semi-comma here. Okay, so the syntax is something you have the same here, right? I have put it on the table. I have it on the table put. They are on the right word, right? All of them is the word is the same, but it's not. This one is not with a proper syntax here. Right? Okay, so the last one is a test program here. Right? It's a test program. Normally in the analyze program, in the analysis right here, you always have to ask a question here. Did I interpret the data correctly? Does the program fulfill the requirement? My formula and process are correct or not? So you think about when working with analyze program here, you also think about the data type, right? So you have to figure out it is data type here. It can be the integer, can be string, can be character, something like that. Right? So we also have to figure out the formula here. So we think about if you want to figure out the area of the rectangle here. So in the analyze here, you have identified the output here is the area, right? So that is output. So for the input here, you know that in order to figure out the area, you need the length and you need the width here. That way, the length and the width here, they are the input, right? But in analyze phase here, you also have to identify what's the data type here. So we think about this one is floating, something like that, right? And this one also, they are floating here. So the first step only figure out what is our expected output, and from that you able to figure out what's our input, and you have to identify what's the data type of them. So when you list out all of the variable, you have to declare variable here. Right? And when you have the variable here, you also have to think about the formula here. So how can you figure out the area? You know that in order to figure out the area, you have to set area here. It's the length time width here. That all of the step here you have to do it in the analysis here, right? And in the design phase here, with the design phase, you know that you have to use the data checking here. So you have the list of the data checking here. You have the list of data checking. So when you run program here, you just stick to the data checking list here. You have to check if it's correct or not. I should think about you have identified the length here is it's a floating, but somehow the end user enter the character or string here. It's not correct. Right? So in the design phase here, you have the data checking to walk through the program here. And in the coding phase, when you working with the coding, you have the error syntax and the logic error here. Right. Okay, so normally you have a four major step. Right? You have four major step in the life cycle here, as a programming cycle here. You have analyze, you have the design, you have coding, and you have static here. And they are the four major steps in the cycle. And some of the cycles, you have some of the additional step here. It can be something about the user guide. You have to create the help file, something like that, right? Everything about the document here. Okay, so we see in order to put the commercial program here, you need to create the user guide. You have to create the help file. You have to train employer to provide telephone or the web-based customer support here. I think about when you're launching program and it go to the commercial. When you sell it out, you have the team just always need to support the customer here by the phone or the web-based customer here, and you have to duplicate the disk and organize the material for the distribution here, and you have to advertise the program here also. That is the additional step here. But basically, you just understand that you have a four major step here. You have analyze, you have design, you have coding, and you have starting here. And programming development is a process. Process that means it is cyclical process here. You always able to go back to fix it. I always go back to fix it here. So it often requires returning to the earlier step. With the complex program, it may take months here. You see, if you think about complicated program, the output is very, very huge. So you always have to require to go back to fix it here. The design process may uncover the flaw in the analysis. So we go back to the analysis. The coding here may find problem leading to modification or addition. You're able to go back. And the testing here is that when you have the output and you compare it with the expected output here, and you go back to fix it here. Okay, so now that is example of the. Let me show this one. What is this? Okay, so here's the example of the sale price example here, right? So the local department store want to develop a program in which, when given the item, original price, and the percentage it is discounted, it computes the sale price with the sales tax here. Okay, so if you look on this one is the problem statement here, right? Problem statement. All right, so a local department store want to develop program in which the given an item original price and the percentage it is discounted, it will compute the sale price with the sales tax here. So if you look on this one, the first thing you have to figure out what are the expected output here. What do you think?
Total price?
Yes, total price here, right? You have the total price here. So we see you have compute the sale price with the sale tax, right? So that's why you need the sale price also, and you need the tax also, right? So this one is optional. It's for me it's optional for this one. But for this one, you have to figure out what is the sale price and what is the tax, and from the sale price and the tax, you're able to figure out the total price here, right? So they are the output. So in order to figure out what is the sale price and what is the tax here, you need something with original price, and you need something with the discount rate here. So they are the input. That's why they are input here, right? So in the first step is analyze. You always have to figure out what are the expected output and what are the input in order to make it the output here. So when you figure out the output and input, you have to name it. Right? That is in the step of the analyze. So you have to put the name for variable, and also you have to identify what is the data type. So you think for all of them, they should be the float here, right? The floating here. Okay, so one you already figured out the output, one you already figured out the input, you have to think about what are the formula is required in order to figure out, right? So you have to think about the formula here. You have the sale price, the first one, the sale price should be the original price minus the amount saved here. So what is it? Here, you see, in order to have the amount saved, you need one more variable here. You need the variable amount saved here. And the amount saved should be the original price times the discount rate. The discount rate is divided by 100 here because it's in the percentage here. Right? So think about that. So you see, when you have the amount saved here, you're able to figure out the sale price equal to original price minus the amount saved. And the tax here is the sale price times 0.07 here. That is a constant here. It's a constant, always 0.07. That's 7%. And the last one, you see, you have the total price equal to the sale price plus the tax here. So all of them here, you have to figure it out in the analysis there. So we see you have to figure out the output, you have to figure out the input, you have to figure out the data type, and you have to figure out all of the formula you need in order to do with the output here. Okay, so you look on this one, you have, when you work in the design here, you break it down in the three processes. The first one is the input, everything you have the input, and you have processing, and after that you have the output here. So we see the input here, you have the discount rate, and you have the original price, and the output, you have the total price, you have the tax, and you have the sale price here, and everything about the calculation here, you have the formula, right? It's the first thing, you need one more variable here, amount saved, it's original price times discount rate divided by 100%. So the sale price equals to original price minus for amount saved, and you figure out the tax is the sale price times the tax rate, and the last you have the total price is the sale price plus the tax here. Okay, so now if you look on this one, everything here is analyzed, right? Analyze it. All right, so you can think about this one, it's in the design here. All right, so now you just convert it into the pseudocode. So you see, actually for this one, you need to declare all of the variable here, but somehow I'm not writing here. You can abort the declare part for this one. And if you think about this one, you have everything about the input, processing, and output here. So you can see everything here is input. And this one, everything here is the processing, and everything here is the output here. So we have input, we have processing, and you have output. See, so in the input here, you don't need this one or whatever. If you want, you can do it whatever you want. It's up to you, but I think it's optional here. So if you look back on the design, you see on the analysis, you see you have the input here, discount rate and original price. Discount rate, and that's why you have the input here. What is the original price here, and what's the discount rate here? So once you have the input, you have to think about the formula here. Everything here is a formula. So you see, the first thing you have to figure out the amount saved. The second one, you have to figure out the sale price. The third one, you have to figure out the tax, and last one, you have total price here. So you see, when you have everything with the input here, you have the original price, and you have the discount rate here. They are the variable, right? So now when we move to the processing, you need one more variable here, amount saved. And from this one, from the original price and discount rate, you're able to figure out something here, right? So next one, you have the sale price here. Sale price equal to the original price minus amount saved. You have something here. And you have the tax here, you say something here, and you have total price, you have something here, right? So when after do everything with the processing, you have some number here stored in the variable name, right? This one is tax, and this one is total price here. All right. So after the processing, all of the variable here already have some of the value. The last one is output. The output, that means you have to access it. You have to access into the memory and print it out to the end user, right? So we see you print it out. What is the item name? What is original price here? This one is the text, right? This one text and original price. It look it up into this one and print it out. The next one is a percentage discount rate. You look it up on this one, print it out. So next one is sale price. It's reference to the memory slot here and print it out. The tag here, reference to the tags and print it out, and the total price, just print it out here. So basically, you have for every program, you have three parts here. You have the input, you have the processing, and you have the output here. Okay, so can you open the Raptor and you try to do with this one? You try to do with coding with this one here, this problem here. Yep. Open the Raptor.
Okay.
Open the Raptor and try with this one here. Okay, so now please open your Raptor and try with this one. And if you have any challenge, let me know. Okay, so if you look on this one, if you look on this program here, you see you have everything is input here. Right? So basically, you have the 1 input, 2 and 3 here, and you do it with the input here, 1, 2, and 3 here. Right? So for the first one, for me, I just copy it here, so make it short. And you store it in the variable name, the item name here. Okay, the first one. Now the second one, what is its price? It's the prom, right? This one is the prom here. And you store it in the variable name, original price. The third one is the prom here. What is its percentage discount? You store it in the discount variable. Okay, so now you've done everything with the input. Right? So next one is everything with the processing here. So when working the processing, you have to do everything with assignment here. Right? So you have the assignment. The first one, you have to figure out what is the amount saved here. Right? So you have to set amount saved equal to this one here. I just copy it here. Original price times discount rate divided by 100 here. Right? The second one, you have to figure out the sale price. The sale price is the original price minus the amount saved here. Right? So again, you do everything with assignment. Edit here. So you have the sale price equal to this one here. Sorry, might be this one. Yeah. So you can save anywhere you want. Okay, so now the next one you have to figure out what is the tax. The tax is sale price times 0.07 here. And you have everything the tax. Set the tax equal to sale price. And you see they have some transaction here, right? And time 0.07. And the last one, you're able to figure out the total price based on sale price and tax here, right? And you have total price. Sale price. Tax here. Okay, so now you see you've done everything with the calculation. The last one is print it out, right? The print it out to the screen here. So the item is that. Everything is the output. So now the output, you just drag and drop the output here. Drag and drop the output and put it here. Everything in the prompt you have to put in the double quote mark here, right? And now we plug it, it's a variable use item name here. See, you have the succession here. Next one, the pre-sale price was another output, another output here. Every prompt, put it in the double quote mark here. All right, now add it with the variable name original here. You see, you have the succession here, original. Another output, the discount rate, right? The discount rate is percentage. Discount rate was and you put it here. It's a discount rate. Yeah, you have the succession here. Is discount rate, and you can put something with text here to make it more sense. And the sale price. And the tax, sale tax. Sorry, tax. And the last one is what you want to print now is total price here, right? So you have the output here. You have total here to make it more sense. Total. Okay, so now you see you've done everything with the coding here. Now you can run. You have many ways to run. You have you can execute to completion here, or you can run step by step here, or you can do with the compile here, whatever it is. So now see if you run step by step here. I see I put the apple here, something like that. Now you see it already stores the item name here is apple here. All right. Now next one. What is on what is its price? 100 here, something like that. What is discount rate? 10%. Next one. So you see, it do everything with the calculation here. You see, you only have the sale price here. Sale price here. Right? So after that, you already have the sale price 90 stored into variable name sale price here. Next one, you have the tax here. Tax this one stored in the tax here. So next one, what is it? Oh, sorry. Yes, this one. So everything here is output. You just do it and you have the output here. So we see you have everything here is output. The item is apple, pre-sale is 100, percentage discount 10%, sale price 90, sale tax here, and the total price here. Okay, so if you run step by step, you just click this one. And now if you want to run by the one completion here, you can do with apple here. And you see the price here, 100 here, and you have the 10% here. Okay, now you do the same. Right? This one you run completion, or you can run it to compile here. You can apple here. And you see, you have everything here. Okay. Any question for this one? Let me know.
Yeah, I'm good.
Okay. Because that is, yes. So that is the way you're working with the adapter. It's very simple. So normally you break it down into the three process here. The first one is the input. The second one is the processing, and the third one is the output here. And in the input, it's everything you have to get the input from end user, right? So the processing, everything is about formula, about the calculation. And the third one is that print it out here. And remember, in order to get the input, you have to figure out what are the output first. Right? So in order to have the output, you're able to figure out what are the input in order to make for here. Now, we go with the program design. So we go with the modular programming here. So to begin designing a program, the first one you have to identify the major tasks a program must to accomplish here, and each this task becomes the program module here. So if you need to break it down the fundamental high level into the submodule, and some of the submodule you even to break it down into the furthermore into submodule also. Right? And this process here can be continued as long as necessary, and you have to identify the task and the subtype is called the modular program here. So here the thing. So the reasons why you have to use the module and the submodule here. So the definition, the module perform a single task. You have to remember that the module is perform a single task. A module is a self-contained and independent from the other module. So it's not really dependent on any other module. It's a self-contained and it can be run by the itself. And module is really relatively short, and ideally the statement should not exist on page here. And the question here, why you have to use the modular programming? What is the benefit? The first one, program is very easier to read. So you think about if you have very complicated program, and if you follow from the beginning to the end, it's very hard for you to follow. So instead of that, you break it down into module. You can look it down. What is this? What is it? And what is it? So you have more understanding on what is the meaning of each of the module here. The first one is very easy to read it. The second one is easier to design, coding, and test the program here because you can do it parallel. You can test and you can design each of the module independently. Right? And the third one is a different program module can be designed and the code in the different program here. So if you think about, you have very complex program. So instead of doing from the beginning to the end, you can break it down into multiple module here. You think about you want to develop a game, So you have the some team here to do everything with the sound, everything here to do with animation, something here to do with custom or fashion, something like that. So by breaking them into the module, you can do it parallel. The first one is a parallel here, and it can do by the different programmer. So some of programmers here, they are very good at the sound design. They're very good at the animation design, and they are very good at the fashion design here. Right? So by breaking down into multiple modules, you can design and they code by the different programming. They do it parallel here. Right? And a single module may be used maybe used in more than one place in the program. So when you have the sound here, you can use it not only one time. It can be this one is module, right? You can call it and you can use it for multiple times here. So we see instead of the doing again and again in the coding, you just do it one time for the module sound here, but you need to coding only one time, but you're able to code it to use it for multiple times later in the program here, right? And the module can perform common programming tasks, can be used more than one program. So it's not only used in this program, but when you have the module, you can use it and you can code it into the another program here. So that is a lot. When working with the modular programming here, you see you have a lot of the benefit when working with that one. So Basically, when working with the modular program, you just break it down into the chart here, right? So you think about you have main module and you break it down into multiple submodule here, submodule. And from the submodule, you even able to break it down in furthermore in the module here. So you see, instead of looking everything from the beginning to end, it's very hard to you to follow. But if you look on the specific module here, it's very short and very helpful for you to understand what is the meaning of the coding here. Okay. Let me see. I have something here. Okay, this one. Okay, so here is an example of the what is it? Okay, so here's an example of the modular programming here. So for this program, you have to figure out what is the area of the rectangle here. So when working with the programming development lifecycle, the first thing you have to figure out what is expected here, and you know that's one is square feet here or area, whatever, right? And in order to figure out the square feet, you need to input here. They need the length and they need the width here. And when you have the output and input here that you identify, you need the three variable here. The next one is a formula here. The formula here, and you see that in order to figure out square feet, you set it the length and width here. So that's one everything with the analyze program, right? So now when you design program here, design program, if you work with the modular structure here, you're able to break it down. Yeah, it's a program here, you're able to break it down into the multiple modular structure here. So for this one, I said that I want to break it down into three submodules. The first one is input here. Input data module. The second one, you have the perform calculation. And the third one, I have the output here. So instead of the whole program, I break it down into three submodules here. Input data module, perform calculation module, and the output module here. And the third one is the coding. For this one, I use Raptor to simulate the coding. And is that I can, after that, the last one is a test program. So I have to test. If I enter the length, it's 10, and the width here is a 5. So my expected output here is 50. Now, to see how it works here. So one thing about the program here, when working the modular structure here, it's up to you. It's up to you. You can break it down into 2 submodule, 3 submodule, or 5 submodule. It's up to you, providing that it is convenient to you. So you think about if you have very, very complicated programming, you're able to break it down into 10 or 20 or more than that submodule. But for the very, very simple program, you're able to break it down into 2 or 3 or 4 or 5, whatever it is, that providing that it is convenient to you. So you don't always have to stick to the input and calculation and output. It's up to you. You can put it the input and the output only, or you can put the perform calculation and output only. It's not always 3 submodules here. So now the next one, you see, you have to break it down into the module, right? So you think about the module here, you have to break it down into the 3 submodule. You have data module, you have a perform calculation, and you have output result here. So everything about this one is the main module. You have the main module here. You think about main module. You have the main module. Everything here, they are header command. The header command, that means you have some information that is very, very helpful for programmer to follow up the coding. And remember everything about the command here. When you execute program, it will ignore it. It never executes it. So it's only helpful for the programmer to follow up the coding only. Okay. So now in the main module, you have to declare all the variable used, right? You have the width, you have length, and you have square feet here. So you see, when you break it down into 3 submodules, you have to call them. Yeah, the first one you have to call the input. The second one you have to call the perform, and the third one you have to call the output here, and you end program. This one is the main module. This one is the main. So you think about you working with the flow with the chart here. You have the main here, and you break it down into 3 here. The first one you have the input here. The second one you do the calculation here. And the third one, you have output here. Okay. So in the main, you call to the input, call the input. You call to the calculation, you call to the output here. Now see, in the main module, when you use the call function in the module, you must define the module, right? So when you see, when you call the perform calculation here, when you call the input here, you have to tell what is the input data and what is the perform calculation. Right? So in that, you have to do everything with the module here. This one's module, this one's module, and this one module. This one is input data module. So we see in the input data module, you have everything with the input here. What is the length? Input the length. What is the width? Input the length. And in the perform calculation module, you have to set the formula here, set square feet equal to the width and the length. And now the output, right? You just write out the output here. So when you looking in the how the call function work, this one is my module here. So we see this one is a header, skip it. Now declare. Now it call input data. So whenever you have the call function here, we locate it to the submodule. So the program here will locate it to the submodule and do everything from the beginning to the end of the submodule here. So the first one, you have to enter the length, you enter the input, and when you enter this submodule, so when you go to the end, you go back to the programming. You go back to the main module, you move to the next one here. You move to the next one. The next one again, the call perform calculation. So when you call perform calculation again, it locate it to the submodule. It do everything from the top to from the beginning to the end here, and do everything with this one. And when we end again, you go back to the main module and you move to the next one here. And again, you call the output result. You go to the submodule, you do everything, and you go back to the end main module here. So that is the way how the call function works. Right? So if you look on the complete program here, you have the main program here. Right? Sorry, you have main program here, and you see when you call, go to this one. Right? When you call, go to this one, and when you call, go to this one here. So now, if you go back to this one, you go back to this one here. You go back to the program here. So this one, you have the whole program here. If you look, it's quite complicated. Actually, for this one, very simple. It's not really complicated, but you think about in the complicated program. If you want to make it simple, you're able to break it down into module here. So for this one, if you want to break it down into an input, in the calculation and output, you are able to do it. So now let me see if you want to do it for this one. If you want to break it down into 3 submodules: input, calculation, and output here. Let me see. So in order to working with the function with the submodule, you have to use the call function here. So we have to use the call function and drag it off here. Click on this. So you have to put the name for the submodule here. So I put this input data here. Okay. Okay. Do we wish to create a new tab named input data? Yes. So you see, I have the submodule here, right? I have the submodule, and for the input data, I do everything with the input. That's why I copy everything in the input here. I copy everything with the input here. I cut it and I paste it here in the input data. I paste it here. So we see in the main function now, I call the input data and it goes to this one here. Now the second one, everything here is the calculation. Right? So I need one module. I need one submodule here. I call it again. I put it here, the calculation. That's all, calculation. Yes. So now for the calculation, I have nothing in the coding, and I have to copy everything in calculation here. I cut it, and I put it calculation. Put it here. Now the last one is everything about the output, right? So I need to call the function output here. Again, I tell you again that you don't always have to break it down into input, in the calculation and output. It's totally up to you. It's totally up to you, providing that it's convenient to you, right? So for this one, I put it output here. Yes. So I see I have one more output here. Now I copy everything here, cut it, paste it into output here. Okay. So now if you look on the program, you see is that is the main program. I have very simple, right? I need the one function is sorry. I have one module is input data. I have one module is a calculation, and I have one module is output here. So now I can look it up. What is input data? Everything is input here. So what is calculation? Everything is calculation here. And what's the output? Everything is output here. So it's way easier for you to follow up with the programming here, to follow up with the coding here. All right. So now to see how it works. So how it works here, I run. All right. So the first one, the main module, you go to the input data. So when you go to input data, it will call into the function of the input data here. You see it look it into the input data here. So again, what is the name? I put it balloon here, something like. What is the original price? 500 here. What's the discount rate? I put 15% here. Now, what happened? When you go with the end of the submodule, what do you think? What is the next action here? What do you think?
Well,
it will come back to the main module. It will come back to main module. You see, when I click here, it will come back to main module and it move to the next step of the main module. So in the next step of the main module, again, it call to the calculation. That's why, again, it go to the calculation here. You see, you have everything here, everything here, everything here. Now again, it end of the submodule. Go back to the main module. Go back to main module and move to the next command here. And again, it call to the function. It call to the module output. Again, it go to the output here. See, you have output here. And end program. So see, you have, I have this item here, balloon, 500, 50%. I have sale price, I have sale tag, and the total here. So you see, by breaking into the module structure, it's way easier for you to follow up with the program, right? So you see, you have input, you have calculation, you have output, and you have input here, calculation here, and output here. Now see, what happened if I want to do one more time? This one is not the balloon. Let me clear this one. If I want to do it one more time with the calculation, I say I want to do this one is not balloon, but this one maybe the books, something like that. Right? So I can use it. I can reuse it here. Copy here. Copy it here, paste it here. Copy it here, paste it here, and copy it here, paste it here. So here you think I only need to do coding with the input one time, calculation one time, and output one time. But in the main module here, I am able to code it for multiple times. What it is. So you see, it saves a lot of time. You just do it coding one time, but you are able to code it for multiple times you want here. So see, if I run it here, this one I put it is the Apple here, 100. Sorry, 100 here, 10%. Okay, you do everything with the calculation. Now the output. Now you see, you move to the next one. This one, the book here. 500, 15%. Okay, so we see, I just do it one coding here, right? Input here, calculation, and output here. But I'm able to run it for the Apple, and I'm able to run it for the book here. And you see, if we see the output here, I got everything here in the output here. Okay, that is the benefit of the submodule. And if you think about the very complicated module here, program here, it's very a lot of benefit when you break it down in the submodule here. So very easy for you to follow, and you can assign the team to do the parallel. And for each of the team, they are very specialized at something here. So we think about someone is very good. Think about you had a project of building a new house, right? So some of them very good at plumbing, and some of them very good at electricity, and you have to break it down in the submodule. You think about that. One team to do everything with the plumbing, one team everything to do with the painting, one team to do everything with the electricity, and they can do it parallel. And when someone is very specialized in plumbing area, they have nothing to do with the painting and electricity here. Okay, so by working with a submodule, you can do it parallel, and you can run it multiple times, and you can use a specialized team to work on this one here. Any question for this? Any question? Let me know.
No, I'm
good.
Okay. So here, in order to call the module, you have to use a call statement here. Right? If you look on this one, you see if you look on this my example here, when working with a pseudocode, you have to use a call statement here. Right? You have to use a call statement here. So what happened when a call statement calls a submodule to be executed? Right? So when you call when you have the call statement here, it calls to the submodule. And when you call the submodule, it do everything from the beginning to the end, right? Everything from the first statement until the last statement. So when you do with the last statement here, it will go back to the main module, and you move to the next statement in the main module here. That's the thing you have to remember about how it works with the calling module here. Okay. And if you look on this one, the main module is very simple. It's a call submodule, and call submodule. So when you call the submodule here, you have to define what is the submodule. Right? So we see you have something about the submodule here, everything about the input, everything here about the calculation, and everything here is the output here. And the output, of course, the output format is very, very simple, very necessary, right? So instead of print out the converting from the Fahrenheit to Celsius, you put the number here. It not really makes sense. Instead of that, you can put it 81 degree Fahrenheit is 27 degrees Celsius here. It makes more sense, right? So basically, when working the design, when working with the modular structure, you have to work in the hierarchy chart here. Hierarchy. So you see, you have the main module. You break it down. For this one, you break it down in 3 modules, and for each module, again, you are able to break it down furthermore in the submodule here. Right. So it's like an organization chart, right? The show position of module in the program. So we see this one belongs to main module. This one belongs to main module. This one belongs to main module, and this one here is the submodule of the module B here. So the third one, you see, you only have the analyze, right? Analysis, you have the design. Analysis, you see, you have everything is output here, input here, formula here, right? Everything that's in analyze, and the data type here, and variable name, something like that. And for this design, you can break it down in the submodule. You can use the hierarchy chart, or you can use the pseudocode or flowchart here. Now it's the coding, so the coding, documenting, and the testing here. So when you have the design, you just stick to the design and translate it into the coding here. The coding is done in specific programming language. For this class, we use a pseudocode, and normally this phase only begin after the solid design exit here. So when you have already solid design exit, you can translate it in the coding here. And you have the documenting. The code need to contain the documentation that requires the reader what is the coding is. So if you think about the complex program, some of them very, very complex here. So it's better if you put some of the header into. Sorry, it's better if you put some of the comments in the coding, so the programmer able to follow up with you. So you think about this one. All of it here, they are the header comment at the beginning of the program, at the beginning of the program here. So when you execute program, the program ignored. They have no benefit in the program execution here, but it have a lot of benefit for the programmer to follow up what is going on with the coding here. You see, they are the header command, and this one is the inline command here. I tell you what is it, tell you what is it, and tell you what is it here. Okay, so you have the two type commands in the coding. The first one is internal documentation here. It's for programmer. So everything here is the internal command here. They are internal command. The second one is external command. It's for the user. You think about user guide or helper, something like that. They are the external documentation here. Right. One more thing you have to remember: the command here will not processed by the computer. It's only benefit to the programmer only. So you have to something about, if you look on this one, when you execute program, they have no difference between the header, between the command or not. If you don't have it, or you have, they have no difference here from the computer perspective, because when you execute it, they will ignore everything here. But it's very, very helpful for the programmer to follow up what is going on with the coding here. So you have the header command. Normally it appears at the beginning of a program or module and provides general information here. And you have step command or inline command here. So normally for the command, it's starting with this one or this one here. So whenever you have this one or this one, when you execute program, the computer will ignore them, and it's only benefit to the programmer only. Okay, so we see this one is example of using the command for program to find the size of room. Everything here is a header command. So header command provides some of very, very general information. So what is the purpose program here? What is the name, what's the purpose, and who is the programmer, and what version of program here? So the first time you do is the version 1, second one you do is the version 2, something like that. And this one is the purpose. This one's the name, and this one purpose here. And you have to tell what are the variable used here. So that's all of them. They are the header. They are the header command. So they have giving out some very, very general information for programming. And this one inline here, it tells you that you're starting with the step of the declare variable. This one is the inline command or step command here. It tells you that you have to get the value of the dimension, and you have calculation and the output here. So for this one is program. Actually, if you look on this one, very, very simple. But in order to make it benefit to the programmer, you should put some information in the header command here. So when you come back to the router, here, basically the router, you are able to enter the command also. But you can put the inline command or header command, but for me, I just require from now on, if you're working with the router, you have to add the header command here. So in order to do the header command, you can right click it here. Yes, I put the command here. So you think about this program to final file. After discount and tax, something like that. That's the first one. And if you look on, let me see. Yeah. So the next one is the next one is the programmer here, right? So we put the name. Now version is the version 1, right? Because I just do it once. Version 1. What's next? Here's the purpose. You can go with and you have the variable use. So variable use. This one you need something about original price. Original price. Discourage. Discourage tax, and final price. Like that. That is very simple information about the header comment here, and very general information. Okay, so we see, and from now on, remember when working with the Raptor, you have to include the header command here in your program. Okay, so now you do everything with the analysis, you do everything with the design, you do everything with the coding, and last one is the testing here. The testing is you have to create the test data here that we need to check the program correctly, right? And you use a that checking here. That checking is something you will be working in the design step here. So we have the list. You have the list of that checking. You have to make sure that it's matching with the output or not. Right? You think about if you want to make cookie, you have to say how many, fine, is correct or not, fine, right? It's crunchy or not, right? Crunchy or not, you have the chocolate chip or not. So list of the step, it's a list of that checking here. You have to follow up and you check it to make sure that the output is what you expected here. And you have error, you have syntax error here. So syntax error is a violation of the programming language. I can create a valid statement here. It may be caused by incorrect grammar or punctuation or misspelling keywords. And for the syntax here, and error, the program will not run with the syntax error. That's what you know, right? So when we have the syntax error, the program will be stop and it gives you some error notification and it will not be run here. The logic error, the program run normally, but not produce the expected result here, right? Okay, so when working with commercial programming, you have the testing and documenting here. You have some of the external documentation here, right? So the documentation you have can be the user guide or the help here, or the documentation on the maintenance manual here. And for the user guide, usually written during the alpha or the beta test by the technical writer. And for the documentation for the other programmer, you can have a programmer maintenance manual here. For the programming experts, you use app and fix enhanced code writing by the programmer here, and in design documentation, and some of the other information here. Okay, so now we move to the structure programming. Right? Structure programming is a method of design and coding programming systematic here and organized manner here. It combines the principle of top-down design. Think about the top-down design is everything about flowchart here, right? From the top to the down, or the modular structure, you break it down, right? In hierarchy chart here, the main module, and you break it down in the submodule here, and submodule here. And you have the three accepted control structure: sequence, repetition, and the selection here. So you will see a lot of the working with structure, sequence structure, repetition structure, and selection structure on the upcoming module here. And the sequence number, repetition, and selection can be expressed in the pseudocode or with the flowchart here. A pseudocode or flowchart, you can do both of them. The first one is a flowchart here. Flowchart is a tool for the programmer to design to program here. They describe the flow of program module execution with diagram here. And it's completely different with the hierarchy chart. So when you think about hierarchy chart, it is when working the modular structure. You remember that, right? So in the hierarchy chart, you break it down in the main module here, and you break it down in the submodule here. So you have A, you have B, and you have C. This one is totally different. Flowchart is totally different. So flowchart is everything in the order from the top to the end here. And the connected symbol are used in the describe the sequence, repetition, or selection structure. And some prefer to use a flowchart to learn how to express algorithm, and others prefer to use a pseudocode here. So it's up to you. You can use a flowchart, so it's very easy for you to follow, or you can use a pseudocode. It's up to you when you design a program here. And many programs designed with the combination of pseudocode and flowchart also. And here is some basic flowcharting symbol. You have terminator here that represents the start or the end of the program. So you have the start or the end here. You have process. You have process. You think about everything about the processing setting, about everything about calculation here. So we set x equal to y plus z. Everything about the processing here. And you have input. That means you have the prompt and you store the input. And this one output also. You have the print out the output. And this one decision. A decision that you have the yes or no or correct or not, and you do something decision here, and you have connector here. It's in entry or exit from programming segment here. Okay, so here is a simple program. Simple example of the pseudocode and flowchart here. Everything here, they are pseudocode, right? Is a pseudocode here. So you see, for this one, you have everything here is comment. You have declare. So in the declare here, it's a main module. You have three you have the three sub module here. You have core input, calculation, and the output. So you have everything here is a sub module. In the input data, everything here is the perform calculation, and everything here is output here. That is a pseudocode. Okay. But if you look on this one on the right here, they are the flow chart here. You see this one here. They are terminator. Start and end here. This one, everything here they are the input or output here. So this one is the input, this one is the input here. Everything on the rectangle here, everything is the processing or calculation here. You see everything here is calculation. And the last one is output here. Sorry, here is a calculation. And the last one is output here. So we see this one input, this one processing, and this one output. So it's up to you. You can use a pseudocode, or you can use the flowchart. It's up to you. Or you can use a combination of them. It's up to you. Okay. Now we move to the control structure. So basically, in the for the computer, you have the three basic control structure here. The first one is sequence. It executes statement in the sequential order here. That do it everything in the order, right? From beginning to the end in the sequential order here. The second one is a selection. It selectively executes the statement here. So in that case, you have to check the condition here. Right? So if yes or no. Right? So if yes, do something here. No, do something here. That is selection. And repetition, also you have the condition here. If yes, it's correct, do again, do again, do again. If no, you exit it here. So basically, you have three basic control structure: sequence, do it everything from the beginning to the end; selection, that do it on the branches here. This can be this branch or this branch; and repetition, check the correction. If correct, do it again, again, and again here. Okay, so if you look on the flow chart for the typical decision here, you can see this one here is selection. Right? This one is selection here. Right? This one is selection. Check the condition. Yes, do something. No, do something here. Now this one again. If yes, do something. Yes, do something here. No, sorry, no, do something. That is selection. It's working on either this branch or this branch here. So this is the loop here, right? So think about the loop. You have the condition. If yes, do it again, do it again, do it again until it no, right? Until it no here. So here's an example of the loop structure here. And you have the style pointer. Normally, if you have a complex program, you break it down in modular structure here. And you have the descriptive variable name. Remember, variable name is very, very important if it's a complicated program here. So try to make the name more meaningful and make it short here. So instead of using X, Y, Z here, you can put it very more meaningful, the ball or price or something like that. It make more sense, right? And provide a welcome message to the user, only way to tell the user what he have to do. So try to use the prompt very, very often here. So please enter the price for a ball, something like that. Try to make it more sense, make it more meaningful to the end user here. Try to use the prompt before the input and have identify the program output and to document the program also. Right? So you have to use the header command or or the inline or step comment here very often here. Okay, so basically that is all for the slide of this week. Let me see what you have in the homework here. Any questions so far? Let me know.
Yeah, I'm good.
Okay.
In order to understand what a software tester or quality assurance analyst does, you first need to understand the process by which the software is conceptualized, developed, and maintained. This process is known as Software Development Lifecycle, or the SDLC. There are 7 key points to understanding the software development lifecycle. Phase 1, planning. Phase 2, requirement analysis. Phase 3, design. Phase 4, implementation and coding. Phase 5, testing. Phase 6, deployment. And Phase 7, maintenance. So it all starts with this guy, the customer. He's the guy that has the business idea for our invoice application and the money to get it started. He's going to reach out to multiple different tech companies until he finds one that he likes. Finally, he's going to meet our company's product owner or our project manager. They're going to discuss terms of their agreement, sign a deal, and accept the project. This will move us into the next phase, planning the requirements. Together, the customer and the product owner will outline the requirements of the application. Let's imagine that the requirements that they've both agreed upon are as follows. 1. User registration. 2. Login. 3. Logout. 4. The dashboard landing page. And so on and so forth. Throughout this course, we'll be running multiple iterations of the SDLC, to which new requirements and new features will be added. Now that we have the outlined requirements, let's take them and move on to the requirement analysis phase. Here's our team: operations, developers, product owners, and testers. We'll all meet up in an office for a few hours and define each outlined requirement and give more planning details. Let's start with requirement number 1, user registration. We'll need a username input field, a password field, a checkbox to accept the terms and conditions, a submit button, and the ability to save the user into our database. Then we'll move to requirement number 2, the login. We'll need a login page to allow returning users to log back into our system. For this, we need another username input field, a password field, along with another submit button. From this, we'll need to read the user's information out of the database and log them into our system. Requirement number 3 will require a logout button, usually located around the same area where the user was logging in from. When they press the logout button, it should clear their session out of the browser to prevent other people from returning and logging back into their account. Finally, requirement number 4, the dashboard. This will essentially be the home page of our application. After a new user is registered, they should be redirected to the dashboard. Also, when the user logs in with the returning account, they should be redirected to the dashboard. For our first SDLC, I will keep the requirements easy. In upcoming videos, we'll dive further in with much harder customer requirements. Once all of the requirements have been analyzed by the team and defined, the product owner will take all the defined requirements and create tickets in a project management system. From here, we'll move into the design phase of the SDLC. The design phase takes all the requirements and starts to plan the product. The design phase may include the business rules, the user interface layouts, color schemes, what programming languages to use, frameworks, system server design, database relationships, architect of the application, mobile aspects, supported browsers, and much more. Next, we'll discuss the implementation and the coding of the application. The implementation and coding phase is where everything starts to become fun. The operations team will set up the physical hardware for the servers, the developers will start writing the code, the designers will continue planning the user interface, and the testers will analyze the requirements and start building test cases for their test plans. Even in this stage, testers are incredibly valuable. They start to imagine the usability of the application and see how everything flows together. Sometimes while writing test cases, they can discover things don't make sense and help redesign fundamental flaws in the early stages of the application. Next up, we'll be discussing one of the most important phases, which is the testing phase. So why is the testing phase so important? Well, imagine that the developer has finished coding some of our new features and our requirements. We found that when the user logs out, that it's not actually clearing the session in the browser, and that another person can walk up to their computer, click the login button, or click the refresh on the page, and they gain access to their account, get access to all of their money, and start making payments on various things. It would be a huge and expensive, terrible bug that would get released if we didn't have testers to test these types of things beforehand. So what does a tester actually do during the testing phase? Now that we have the servers all set up and the database is set up, developers have finished coding, they've given us an application, an actual website that we can log into now. Now we can start testing and executing our test cases from the test plans that we've created, validate that all of the requirements have been met, make sure all the functionalities work.
So here you can think about that checking here. That's the list of the testing step you have to create out during the design step here.
As expected, find as many bugs as we possibly can, which could be color scheme is incorrect, or if there's a user interface bug somewhere, a critical issue of people not being able to log out, maybe the users can't even register. There's so many mistakes that the developer can make and do make frequently. So as we're testing, we start to find bugs, and what we'll do is we'll report them into a bug tracking system, which is then assigned to a developer. They'll go in and they'll fix the bug, fix the issue, and assign it back to us. This is called a bug lifecycle. You may have noticed that I've mentioned test cases, test plans, and bugs. In the upcoming videos, we'll go into the bug lifecycle, iterating with developers, and how to write test plans and test cases. Up next, we'll talk about the deployment phase. The deployment phase, the operations team will end up mirroring the staging or development environment systems that we've been testing in and get them ready for production, meaning that they'll install new hardware, brand new servers, have everything scalable for production. This includes setting up the links, setting up the databases for real users, syncing up with the development teams and release managers. Once they've completed all of these tasks, our application will go live to real users. This brings us to the final phase of the SDLC, maintenance. So imagine that we've released and our application became so successful, we're just getting millions of users logging in and registering and using this application. So we need to maintain the servers in the environment. They need to monitor that the load, the stress, everything coming on the servers by so many users logging in and using it, it doesn't bring down the system. Maybe we need to make larger servers, larger databases. Maybe we need to get faster computers. There's a lot of stuff that goes on during the maintenance phase. There will be bugs found in production. It's called production support. Frequently, users will email with their issues, and you can stop and investigate what they're complaining about or what their issue is. Figure it out, write up a bug, get it resolved, and do another deployment to production with the issues fixed. So to summarize, we've discussed planning, requirement analysis, design, implementation and coding, testing, deployment, and maintenance. All right, awesome. That wraps up the video on the SDLC. One last thing to
think about this one. Yes, this one is good one as well.
Welcome back to Program Logic and Design. In this section, we're going to be discussing our pseudocode statements and our flowcharts. All right, so what we're going to be chatting about is pseudocode. Now, what is pseudocode? Pseudocode is an English-like representation of the logical steps it takes to solve a problem. So if we have a look at our making a cup of tea here, we organize everything together. We plug in the kettle, we put the tea bag in the cup, we put the water into the kettle, we wait for the kettle to boil, we add water to the cup, we remove the tea bag with a teaspoon or a fork, we add milk or sugar, depending on our preferences, and then we serve. It is in a logical order, and we haven't eliminated some of the important steps like boiling the kettle. All right, next we have our flowchart. Flowchart is a pictorial representation of the logical steps it takes to solve a problem. If we have a look at our problem here, it is pictorial. I'll discuss all the different shapes for you and what they mean later. But just what you need to know is that you go, lamp doesn't work. Okay, lamp doesn't work. Is it plugged in? If it's not plugged in, then we plug it in. If it is plugged in, then we're going to check the bulb. Is the bulb burnt out? Yes, it is. We replace the bulb. If it's not, then we repair the lamp. Then something's definitely wrong with the lamp. Now, I'd like you to think of pseudocode and flowcharts as of a map. When you give a friend directions to your house, the friend will either write down the directions. You turn left at this road, you turn right at this road, and on your right-hand side will be my house with the number 2 or 3 or whatever it is. Or you will draw the map, literally draw it. You will draw the road, you will draw this road intersects this road, and this road's called this road, and then you probably draw a flow line on how to get to your house on the roads which you have drawn. So that's basically what pseudocode and flowcharts is. It depends on what your client prefers. Most clients prefer flowcharts because it's more pictorial, it's more an understanding for them is pictures. All right, let's discuss how we actually write pseudocode. Pseudocode representation of our number doubling problem. What we have is we've got start, we input my number, we set my answer equal to my number times 2, output my answer, we stop. We've already discussed it, but what I want to show you is the standards of writing pseudocode. Your programs begin with start and end with stop. These two words are always aligned. If you have a look, start and stop. Remember, you can also use begin or end. It's your preference, as long as it's understandable and they are aligned. Next is each program statement performs one action. For example, input, processing, output. All right, so input my number, we process my answer using my number multiplied by 2, and we output my answer. See how they are all directly aligned underneath each other. Program statements are indented a few spaces more than the start or the module name. All right, we'll discuss modules later, but you can see a few spaces is indented from that. As you can see, I've actually left out the second and the third one. We'll discuss that when we do modularization, which is much later. Now, each program statement appears on a single line, if possible. When this is not possible, continuation lines are indented. So we will have that on a new line. And if this was a long processing, you would just indent a few spaces and then carry on writing. Okay, you'll see this later when we write bigger programs. Program statements begin with lowercase letters. This is why I like you guys using Notepad++, because you won't have a problem of auto capitalization, which Microsoft Word does for you. You can always right click on, I'll show you later, right click on a drop down menu to make sure that it doesn't have the auto capitalization, but I'll show you that later. All you need to know now is just please make sure that everything is lowercase. And last but not least is no punctuation is used to end statements. So there's no full stop after stop or end, which brings us to drawing flowcharts. Now, these are our flow lines. They connect shapes with arrows. You draw geometric shapes that contain the individual statements. That's how you create a flowchart. If you have a look at my input symbol is a parallelogram. I don't know if you remember what the shape is called from maths, but this is a parallelogram. It indicates an input operation. And my processing symbol contains processing statements such as arithmetic, like my answer equals my number multiplied by 2, and it is a rectangle. My output symbol is the same as my input symbol. It is a parallelogram, and it represents our output statements. Our flow lines, which is the arrows, it's a line with an arrow, shows our direction, and this connects our steps. Our terminal symbols is start, stop, begin, end. They are our terminal symbols. We terminate our pseudocode or our program with a start, and we terminate it with a stop. Start and stop symbols, they're shaped like a racetrack, and we also call them a lozenge. So a lozenge is like a tablet. So a lozenge is more fancy word for a tablet. Drawing flowcharts, our continuation is, here's an example of our doubling a number program, which we've did previously. We have our lozenge, which is our start. It's our terminal statement, start to stop. Then you have your flow lines, which says, okay, from start, you flow towards my parallelogram, which is my input, my number, which is our input. Then we process. So my flow line goes towards my processing here, which is my answer. We're processing what my answer is going to be, which is my number, whatever we input it in, multiplied by 2. Then we flow towards our output answer, output my answer, and that's also parallelogram. For pseudocode, we will just go start, input my number, set my number, my answer to equal to my number multiplied by 2, output my answer, stop. Indented, indented, new line, new line, new line, new line, new line, lowercase, 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 lowercase. Now, I would like you to think, all right, which is the better tool for learning programming? Is it flowcharts or is it pseudocode? There's a very interesting article which I have given you on the structured flowline niche. What they actually did is they took a couple of students and they said to them, which do you prefer? Do you prefer structured flowcharts, which is a complex algorithms using a graphic method, or do you prefer verbal method like pseudocode, like writing English in like an English-like manner? And what was interesting is that 75 to 89% of the students actually preferred flowcharts. And then they went on to say, okay, how strongly do they actually feel about flowcharts? Please have a read through this article. It's just a little bit of just the abstract version of it. It's quite interesting to see what people actually think about flowcharts. Some of you might actually think that pseudocode is better or flowcharts is better, but it is a personal preference in the long run. To be honest, I preferably.
Okay, so let's see what you have for this week. So what do you think about this one? The question 1 here, what do you think? If you look about this one, yeah, style portal, right? Variable name, provide welcome message, prompt, output, document the program here. So we can tell what is this. And algorithm, what's the algorithm?
It's all of these.
Summary design includes step-by-step instruction, terminate and final time. Yeah. What is this? What do you think about this one?
Input, output.
Yes. So it's
input, output. Yeah.
Yes, input, output. So what about this one?
Terminator.
Yeah, terminator. Which of the following is not benefit of modular programming?
Is it the last one?
Which one?
Or the last one, I think.
This one?
Uh-huh.
This allow one programmer to do the job in many. No, actually, it's when working in modular structure, right? So when we develop one module, you can use it for multiple times. You can use it for multiple times.
Is it the second one?
Yeah, I think
allows for the creation.
Yeah, I think this one. This one is it. Flowchart here. What do you think?
Decision.
No, this one the processing here, right? The processing, everything is assignment. Like you said, x equal to y plus z, something like that. That's everything about the processing here. Which one? Which one is most likely to be found in the output data module?
Is it the last one?
Yes, this one is the calculation, right? This one is the input,
Uh-huh.
and this one is the output. And normally you have to learn with the variable here, right?
Yep.
Yeah, this one is it. This one is decision, yes or no, right? It breaks it down.
Decision.
Yeah, into the branches here. The 9. Which one is true?
The contents of comments are ignored by the computer while running a program.
Yeah, right. Because everything is a command. It only benefit to the programmer only, but it have no sense, no benefit to the computer here. Input data module.
Write the average of the three.
Yeah, the third one.
This one the prompt, right? So we have to enter here. When what? Running,
runs.
Executed or whatever.
Probably executed running.
Yeah, I don't know. In structure, the branch for some point, causing a point program to skip. So if you come back to the three basic structure, you have sequence, you have the selection, and you have the repetition here, right? So in the selection, it's something right, do something, or if no, you can skip it, or you can do something here. So this one is, yeah, this one is selection, right? It always skip someone. So if yes, do the yes and skip the no, and if no, do the no and skip the yes here. An algorithm use a computer program must be verified well ordered, no gap in instruction, and programmers must contain a clear step-by-step instruction. No step, not even more basic. What is it? Contain a clear.
Concise.
Yeah, maybe. I'm not sure. Can go back to the definition here. Yeah, maybe. And another term for repetition is loop, right? The most common one they can use loop. The loop here. Module. What is it? It means the cause the execution to transfer to that module. So if you remember about when working with the submodule, right? So whenever you want to call the function, you have to use the call function here, right? So this one's a call here. You have to call. The way that specific words and symbol are used in each language is called syntax. Right?
Syntax, yeah.
A tool is by programmer to design program before writing. Actual code is
Pseudocode?
Pseudocode?
Yeah, pseudocode. If a task run turn up problem, yeah, there are task run turn up problem. You must
Debug.
You must what?
Debug.
Ah, okay, debug it. Okay. Which kind of error? Which kind of error occurs result of the following statement? What do you think?
A logic error.
It's a logic error.
Yes, the output must be something here, right? Output must be here. Output here. Another term to describe walking through the program to see the expected result is called dash checking or something like that. Right?
Mm-hmm.
When using the following symbol, there are two arrows coming out with one arrow. What happened if it is correct? Something like that. It's a kind of the selection here. Program is a method used to design and code program with system organized manner. Design and coding. What is it? You can see
Structured.
might be. I'm not yet sure about that. Sorry. You can look it up. And use incorrect formula to produce the desired result. The type what?
That's syntax.
No, it's actually the logic. Right? The incorrect formula is a thing giving out the output, but not what you expected. So it's the logic. Yeah. Connector are represented.
Circles.
Okay. When you began to analyze program in program, the first thing you need to do is
Output.
Yeah, the first thing always output here. What is okay, so now what is it? Checkpoint. It's very simple, right? The adapter program that receives the first name and the last name separately from the user, and program will display the hello here. It's very simple, right? So for this one, you have the two input here. You you need one prompt ask the user to enter the first name, and you need one more prompt to add the user enter the last name, and the last one when you display it, just concatenate them together. Hello plus the first name and plus the last name here. And remember, try to use the space or whatever to make it more sense to the output here. And one more thing about this week here, I need to let you know about this one. From this week here, from this week, you have to working on progress report here. Now this will run from this week until the last week here. So basically, you are expected to do it on the weekly basis and do it progressively here. Don't wait until the last minute because the project here is a quite long project. So I strongly recommend you to work on the weekly basis. So even that some of the week, this week is not graded, but I still really strongly recommend you to working on the weekly basis here. Don't wait until the last week. It's kind of a huge project here. Okay, so for this project, what is this project? You have to download this one here. This one's the report here. Okay, so for this one, it's not graded. Remember, for this week, it's not graded. But again, remember that you try to work it as soon as possible and do it on weekly basis and progressively here. So for this report, you will focus on depositing into the single account, create a drafter program with the account detail for the customer below, allow Robert to deposit his account after transaction is complete. The program will update running balance with the customer detail description and question. Do not be concerned about authenticating the user in this module. All right. Okay. So documentation is very important here. Normally you have to include the header command in the router here. Right? So For this here. Okay, so this program is at the beginning. You set the customer name is Robert Brown, username R Brown here, and he initial account balance is 2,500 here. Right. So all of them, you can think about they are the input here. Now you have to ask him the how much money you want to deposit. Right. So you got it from him, and after that you have to update what is the new balance here. That's very simple for this one. Right. That is very, very simple for this one. And let's see. And the homework assignment. Okay, so one thing about the homework assignment here, you have for this one here, both of the you have to work on the three pseudocode here. Challenge 1, challenge 3, and challenge 3. But remember that for all of them, you must incorporate the modular programming here. That means you have to break it down. You have to break it down into the module here, into the submodule. I remember that it's up to you. You can break it down into 3 submodule, 2 submodule, or 5 submodule. It's up to you. Totally, it's up to you, providing that it's convenient to you. But remember, you have to break it down into modular structure here, because you will see that when working with the modular structure, you have a lot of benefit. And when working with the project here, the final project, it's quite a huge project. So you will see it have a lot of benefit when you break it down into multiple submodules here. Okay, so I think that's all for today. And on Wednesday, I will go a little bit with and go a little bit with the diagram structure, and I will go with a little bit with the introduction discussion here, because in this one here, you have to working with you have to working with oh no, this not this one, sorry. I'm gonna go to this one. Yes, this one here. So this one you have to go with the universal backup language here. So we understand how to working with the UML and how to work with this one, and you have some instruction for this one. So I will reserve it to the Wednesday, and on Wednesday I'm working on this one and working with the homework also. I will provide some of the guideline to how to working with the homework, how to working with the modular structure here. So do we have any question? Let me know. Any question?
No, I'm all right.
So if you don't have any question, we can end the class now, and I'll see you guys on Thursday.
Thanks. Have a good one.
Okay. Bye-bye.
Bye.
Bye.